The next chapter which we deal in physics is about simple harmonic motion and angular harmonic motion. In this chapter the questions are pretty simple and you will have to solve the questions simply by applying direct formulae, and you can solve the questions faster if you know the concepts well. Now let us start with the first question. In the process I will tell you various tricks which you can use in various other questions also. So in this question we have a block hanging from a spring. We know that a block hanging from a spring under the influence of gravity, the motion of this object is simple harmonic motion. We already know that. At the highest point of oscillation, the spring is at its natural length, that is the spring is unstretched. We need to find out the maximum speed of the block and the speed when the spring is stretched by 0.20 centimeters. So now let us draw the diagram of the motion of the block. This is the initial position when the velocity of this block is 0 and the spring is unstretched. We know that velocity of an object is 0 in an SHM at the extreme position. So this is definitely the extreme position for the block. Now since this block is experiencing a force mg downwards and no force in the upper direction, it has an acceleration in the lower direction, due to which it moves in the downward direction. Now the next state comes when the block is stretched by x. If this is the equilibrium position, then kx is equal to mg, that is x is equal to mg by k. So after coming mg by k distance downwards, the spring exerts a force equal to k into mg by k, that is equal to mg in the upward direction, which balances the mg, due to which the net force on this block becomes 0 and this becomes the equilibrium position of the block. We need to find out the maximum speed of the block. Now we already know the maximum speed of the block comes at the equilibrium position, and that is equal to, and magnitude whose magnitude is equal to a into omega. We already know the value of t. Omega is equal to 2 pi by t. Let me write it here. Omega is equal to 2 pi by t is equal to 2 pi into 10 is equal to 20 pi second inverse. So we know the value of omega. We already also know the value of a, that is equal to mg by k. We need to find out the value of a into omega, that is equal to mg by k into omega. Now we know that in SHM k is equal to m into omega square. So we substitute m omega square over here. Since omega is equal to root over k upon m, therefore we have k is equal to m omega square. Therefore we get the maximum speed to be equal to g upon omega. The value of g is given to be pi square meters per second square. Therefore pi square upon omega, that is 20 pi second inverse, to give the value of maximum speed as pi square upon 20 pi meters per second, that is equal to pi by 20 meters per second. So we get the answer for our first part, which is the maximum speed of the block, by simply applying the simple various concepts of simple harmonic motion in a straight line, that is linear simple harmonic motion. Now we need to find out speed when the spring is stretched by 0.20 centimeters. Now let us first find out what the amplitude comes out to be. The amplitude was equal to mg by k. K is m omega square is equal to g upon omega square is equal to pi square upon omega was 20 pi, that is over 100. Pi square is equal to 1 upon 400 meters is equal to 0.25 centimeters. Now we need to find out the speed of the block when it is stretched by 0.20 centimeters. Initially the block's velocity was 0. This was the extreme position. We have already found out that at the equilibrium position, the displacement of the block is 0.25 centimeters. Now we need to find out the speed when spring is stretched by 0.20 centimeters. Over here the spring is stretched by 0.25 centimeters. The state which we want to analyze is when the spring is stretched by 0.20 centimeters. We need to find out the speed of the block at this instant. Now we already know a formula of the speed of an object in SHM as a function of the displacement from the equilibrium position. That formula is V is equal to omega root over a square minus x square. Mind you, in this formula, x will not be fed as 0.20 centimeters because this x is the displacement from equilibrium position. Always mind you of this. In all the formulas of SHM, like x is equal to a sin omega t plus theta, v is equal to omega root of a square minus x square, f is equal to minus kx, the x is always equal to the displacement from equilibrium position. So the equilibrium position was this. The displacement from equilibrium position becomes equal to 0.05 centimeters. Now we feed in the values here. V is equal to omega 20 pi root over 0.25 whole square minus 0.05 whole square centimeters per second. So the final answer comes out to be 15.4 centimeters per second. So just by simply applying the simple concepts in simple harmonic motion of a omega v is equal to omega root over a square minus x square omega is equal to root over k by m, we were able to derive the maximum speed of the block that was equal to pi by 20 meters per second, and the speed when the spring is stretched by 0.20 centimeters to be equal to 15.4 centimeters per second.